Hello everyone, welcome back to my channel Explain Maths. Now in this video I am going to explain trigonometric identities as well as I will solve question number 1 to question number 3 of exercise 8.3 of chapter 8. So let's begin the class. So what is trigonometric identities? The equation, trigonometric identity is an equation which involves trigonometric ratios of an angle, and if it is true for all values of the angles involved. So I have taken a right angle triangle ABC. Okay, if you can see, this is a triangle ABC, right angle at B. Now we already know that in a right angle triangle, the square of the hypotenuse is equal to sum of the square of the remaining two sides, isn't it? So by using Pythagoras theorem, what I can write here? So I can write here AB square plus BC square will be equal to AC square. I am going to give this as number 1. Now I am going to divide by AC square on both the sides. Okay, so divide by AC square in 1. So what will happen? AB square by AC square, each term you have to divide by AC square. Same way BC square by AC square equal to AC square by AC square. Now if you see AB by AC, okay, AB square by AC square, I can rewrite it as AB by AC whole square, isn't it? And BC square by AC square, I can write as BC by AC whole square, and AC square by AC square, it will become 1. Now from the figure, if you see, what is AB by AC? We have already studied all the trigonometric ratios, isn't it? So if you consider this angle A, with respect to angle A, this will be your opposite side. Okay, this will be the adjacent side and this will be the hypotenuse. Now AB by AC, if you see, it is adjacent by hypotenuse, and adjacent by hypotenuse is cos A, right? So I can write it as cos A square. This will be cos A whole square plus, now BC by AC. BC by AC is opposite by hypotenuse, which is sine A whole square equal to 1. From here cos A whole square I can write as cos square A, sine A whole square I can write as sine square A equal to 1. So this is your first identity. Sine square A plus cos square A will give you 1. Now this identity we can further use to find the value of cos square A also. Cos square A will be equal to 1 minus sine square A. Okay, you have to transpose sine square A to other side, you will get this. Same way sine square A if you have to find, and if you know the value of cos A, it will be 1 minus cos square A. So this two also you should always keep it in your mind. And this is true for all the value of A, which, and the value of A, it can be taken from 0 to 90 degree. Okay, including 0 and 90 degree. 0 to 90 degree for all the angles, this identity will be true. So this is your first identity. Now I am moving to the second identity. Now again I have taken a right triangle ABC, right angled at B, and using Pythagoras theorem I can write it as square of the hypotenuse is equal to sum of the square of the other two sides, isn't it? So I am writing AB square plus BC square is equal to AC square, and I am giving this number 2. Now for the first identity I have divided AC square on both the sides. Now for the second identity I am going to divide AB square on both the sides. So divide AB square in 2. So what will happen from here? AB square by AB square plus BC square by AB square. This will be equal to AC square by AB square, isn't it? Now next, the AB square by AB square, it will become 1, right? Plus BC square by AB square, I can write as BC by AB whole square, and AC square by AB square I can write as AC by AB whole square. Now with respect to this triangle, if I take an angle A, my BC will be the opposite side, AB is the adjacent side, and AC is the hypotenuse, isn't it? Now from here if you see 1 plus BC by AB. Now BC is your opposite by adjacent, and opposite by adjacent is tan A, right? So it will become tan A whole square, tan A whole square equal to now AC by AB. AC is hypotenuse by adjacent. So adjacent by hypotenuse we know it is cos, and so it is a ulta of that. It's a reciprocal hypotenuse by adjacent. So it will be sec A. So I can write it as sec A whole square. Now further I can write it as 1 plus tan square A equal to sec square A. Okay, so this is your second identity. Now this identity, it can be used in one more way. You should remember it. Sec square A minus tan square A is equal to 1. How? I have transposed this tan square A to the RHS. So I have got this. Now we all know that for sec A and tan A, it is not defined for A value if it is 90 degree, isn't it? So this identity will be true for all the values of A starting from 0 to less than 90 degree. Okay, for A equal to 90 degree, it won't hold true because tan A and sec A is not defined for A equal to 90 degree. We have seen the trigonometric chart, right? For A value, if it is 90 degree, tan A and sec A is not defined. Okay, so this is your second identity. Now moving to the third identity. Again here I have taken a right angle triangle ABC, right angle at B, and we know that by Pythagoras theorem, the square of the hypotenuse is equal to sum of the square of the other two sides, isn't it? So I can write it as AB square plus BC square is equal to AC square. This is my third identity. I'm going to prove from here. Now I'm going to divide BC square in third. So what will happen? It will become AB square by BC square plus BC square by BC square equal to AC square by BC square. Now further I can write it as AB by BC whole square, isn't it? Plus BC square by BC square is 1, and AC square by BC square, it will be AC by BC whole square. Now with respect to this angle A, BC is the opposite side, AB is the adjacent side, and this is the hypotenuse, isn't it? And AB by BC, if you see from the big figure, AB by BC, adjacent by opposite. So it will be cot A, isn't it? This is a cot A. And AC by BC, hypotenuse by opposite, is cosec A. So from here I can write cot square A. This will be cot A whole square plus 1 equal to cosec A whole square. Now cot A whole square means cot square A plus 1 equal to cosec square A. This is your one of the identity. Okay. Now this identity you should remember in this way also. Cosec square A minus cot square A will be 1. Okay. So we have seen three identities. First identity was sine square A plus cos square A is equal to 1. Second, we have seen 1 plus tan square A is equal to sec square A. And the third one is cot square A plus 1 is equal to cosec square A. So these three identities you have to always remember. And this third identity, we know that for A equal to 0, cot A and cosec A is not defined. So cosec A and cot A is not defined for A equal to 0 degree. Therefore, it is true for all A such that it will lie in this range. Here 0 is not included, 90 degrees included. Okay, so you have to remember this also. Now moving to the exercise question. Now exercise 8.3 question number 1. Express the trigonometric ratios of sin A, sec A and tan A in terms of cot A. So you have to find a relation of sin A, sec A and tan A in terms of cot A. So let's do one by one. So now we have to use the identities over here, then only we can able to find it. Okay, so we know that cosec square A is equal to 1 plus cot square A, isn't it? This relation, this identity we have seen. Okay, why I am doing with cosec A? Because I have to find sin A. And we know that sin A is the reciprocal of cosec A. So if cosec A I can write in terms of cot A, then easily I can do for sin A also. Now cosec A, it is cosec square A. I have to get the value of cosec A. So it will be opposite of a square is the square root. Square root of 1 plus cot square A. Okay. So actually it is the square root of plus minus, but we are going to consider only the positive of it. Okay. Now you will be wondering why it is plus minus. Now if you see here, root of 4. Okay, this I'm just giving one example. Root of 4, if if you have to find the root of 4, answer can be 2 also, it can be minus 2 also. Because 2 square is also 4, isn't it? And minus 2 square is also 4. But we always take the positive value. So here also we are taking the positive value. Now once we get the value of cosec A, now I can find sin A in terms of cot A. Because sin A, we know it's a reciprocal of cosec. So I can write it as 1 by cosec A, and which is further can be written as 1 by, now cosec A I have got the value in terms of cot. So 1 by 1 plus cot square A. So this is the first answer. So first answer sin A I have got it in terms of cot A, isn't it? So this is for sin A. Now slowly I will move for sec A also. Okay. So now for sec A also, what is the identity? If we try to remember, we know that sec square A is equal to 1 plus tan square A, isn't it? Sec square A is equal to 1 plus tan square A. We have seen just now, right? So let's write it. Sec square A is equal to 1 plus tan square A. Now here I am getting the relation of sec with respect to tan. But what I have to do? I have to find with respect to cot. But we know that tan and cot both are reciprocal, isn't it? Tan I can write as a reciprocal of cot also. So first of all, let's find sec A. Sec A will be the root of 1 plus tan square A, isn't it? And tan further I can write it as 1 plus 1 by cot square A, because we know that reciprocal of tan is cot. Now let's take the LCM. So LCM will be cot square A. So which will give me cot square A plus 1. And root of cot square A will be cot A. So the answer will be root of cot square A plus 1 by cot A. Okay. Because you can see if root of cot square A means what? Cot A into cot A. So I will get only cot A outside. Now the last one is tan A I have to write in terms of cot A. So this is so simple. Tan A and cot A are reciprocal of each other. So I can write tan A equal to 1 by cot A directly. So this is your trigonometric ratios of sin A, sec A and tan A in terms of cot A. So sin A I have converted over here. Sec A I have converted over here and tan A I have converted over here. So this is your question number 1. So you can see from here that the trigonometric identities how I am using over here to convert sin A, sec A and tan A in terms of cot A. So it's very important. Many places you are going to use this trigonometric identity. So you should be thorough with it. Okay. Now moving to question number 2. Now in question number 2, we have to write all the other trigonometric ratios of angle A in terms of sec. So what are the other trigonometric ratios like sin A, cos A, tan A, cot A, cosec A? All we have to express in terms of sec. So first we'll start with something which is easy. So we know the reciprocal of sec A is cos A. So we'll start from there. So cos A will be 1 by sec A. So first I have expressed cos A in terms of sec A. Now we also know that one of the identity is sec square A equal to 1 plus tan square A, isn't it? Now from here I can get tan square A by shifting 1 from RHS to LHS. So I can write it as tan square A is equal to sec square A minus 1. Okay. But we have to find the value of tan A, not tan square A. So tan A will be root of sec square A minus 1. So I have got the value of cos A, I have got the value of tan A with respect in terms of sec A. Now once we know tan A, then the reciprocal of tan is cot, isn't it? That also I can express. So cot A is 1 by tan A, which further I can write it as 1 by root of sec square A minus 1. Now there is a relation of cot with cosec, isn't it? Cosec square A is equal to 1 plus cot square A. Now I'm going to put the value of cot A from here. So what it will become? It will be 1 plus 1 by root of sec square A minus 1 whole square. And we know that 1 square is 1 only, and root of sec square A minus 1 whole square if you do, it will be sec square A minus 1, isn't it? See, root 2 whole square if you have to do, it means what? It is root 2 into root 2. So you will get only 2. Same ways, root of sec square A minus 1 whole square if you do, you will get this. Now let's take LCM. So LCM is going to be sec square A minus 1. So here it will be sec square A minus 1 and then plus 1. So minus 1 and plus 1 will get cancelled and you will get here sec square A by sec square A minus 1. Now this is the value of cosec square A. You have to find the value for cosec A. So cosec A will be root of sec square A by sec square A minus 1. Okay, and root of sec square A means sec A by root of sec square A minus 1. Now once you get the value of cosec, you can get the value of sine also, because sine is a reciprocal of cosec. So sine A will be 1 by cosec A. So the value which you got here, you have to just write the reciprocal of it. So it will be root of sec square A minus 1 by sec A. Okay, so this is your all the identities. See, cos A is here. Cos A I have represented in terms of sec over here. Tan A I have represented here. Cot A is here. Cosec A is here. And at the end, sin A is over here. So I have represented all the remaining trigonometric ratios in terms of sec. Okay. Now I'll move to question number 3. Now question 3, first one, choose the correct option and justify your choice. So this is like a multiple choice question. And first one is 9 sec square A minus 9 tan square A equal to what? So what I can do from here, from this question, I am going to take 9 common. So I will be here left with sec square A minus tan square A, isn't it? And we have identity, isn't it? Sec square A is equal to 1 plus tan square A. Okay, and when you transpose tan square A this side, what it will become? Sec square A minus tan square A equal to 1. So from here I can write this value will be 1. So it will be 9 into 1, which will give the answer as 9. So the correct option is option B. So this was a very simple question and it was completely based on your identity. So you can see that how important it is to remember all the identities, isn't it? Now second one, 1 plus tan theta plus sec theta multiplied with 1 plus cot theta minus cosec theta. Now these type of questions are very important. So you have to practice more and more. You will see many similar questions in your RS Agarwal and all. So please do practice more and more these type of questions. So here what we will do, I am going to express tan theta as sin theta by cos theta and sec theta as 1 by cos theta. Same way cot theta I can write as cos theta by sin theta and cosec theta as 1 by sin theta. We have remember, right, when I was explaining trigonometric ratios, I have explained all those things, isn't it? Tan theta can be written as sin theta by cos theta, okay? And cot theta can be written as cos theta by sin theta. So you have to remember all this. Now I'm going to use over here. So it will be 1 plus tan theta I am writing as sin theta by cos theta. And sec theta is the reciprocal of cos. So 1 by cos theta. Same way here it is 1 plus cos theta by sin theta minus cosec theta is a reciprocal of sin theta. Okay. Now second step I will be taking LCM. So LCM is cos theta. So here it will become cos theta plus sin theta plus 1 and here it will become sin theta plus cos theta minus 1 by sin theta. Okay. Now you have to multiply. See, from here you can do two ways. You can use identity also. If you consider this as your x, okay, this is also same thing. So cos theta plus sin theta or sin theta plus cos theta. It's the same thing. So it is x plus 1, x minus 1. So you remember the identity, isn't it? A plus b, a minus b. A plus b, a minus b. It gives a square minus b square. So from here I can write x square minus 1. And what is your x? X is cos theta plus sin theta. Okay. That square minus 1 square by sin theta into cos theta. From where I got the denominator? Product of cos theta and sin theta is sin theta into cos theta. Now use here a plus b whole square. So it will give you cos square theta plus sin square theta plus 2 sin theta cos theta minus 1 by sin theta into cos theta. I hope you all remember a plus b whole square, isn't it? You have used multiple times in grade 9 also. It is a square plus 2ab plus b square. Still I am writing it for your reference. Now cos square theta plus sin square theta is 1. We know the identity, right? So it is 1 plus 2 sin theta cos theta minus 1 divided by sin theta cos theta. So 1 and minus 1 will be 0. Now you have used the identity. So please mention here, since cos square theta plus sin square theta is equal to 1. So better you please write the identity also beside it. Okay. Many school they tell to write the identity. Next it will be 2 sin theta cos theta. I am left with this in the numerator and denominator is sin theta into cos theta. Now sin theta cancel, cos theta cancel and I am left with only 2. So the correct option is option C. C is the correct option. I am going to just revise it one more time. First of all, you should remember tan theta is sin theta by cos theta, cot theta is cos theta by sin theta. Now I am expressing everything tan, sec, cot and cosec in terms of sin and cos. So now it is 1 plus sin theta by cos theta and sec theta is 1 by cos theta. Then 1 plus cot theta is cos theta by sin theta minus cosec theta is 1 by sin theta. Then I have taken the LCM. So LCM will be cos theta. So here it will become cos theta plus sin theta plus 1 and here it is sin theta plus cos theta minus 1. So if you consider cos theta plus sin theta as x, so it will become x plus 1, x minus 1. And we know the identity, right? A plus b, a minus b is a square minus b square. So if you use that identity, it will become x square minus 1 square, isn't it? Now what is your x? X is cos theta plus sin theta. So I've replaced here cos theta plus sin theta whole square minus 1 square. And here then I have expanded as a plus b whole square and 1 square is 1. Again I have used the identity cos square theta plus sin square theta is 1. So 1 plus 2 sin theta cos theta minus 1. So 1 and 1 will get cancelled. Now 2 sine theta cos theta by sine theta cos theta. Then sine theta cancel, cos theta cancel, and I'm left with only 2. So this question is little lengthy. It may come in 2 mark or 3 mark question also. Though here it is asked in MCQ, but it's a very good question for 2 mark or 3 mark question also. So again I'm repeating, please practice these type of questions from your some other reference book like R.S. Agarwal or R.D. Sarma, whatever is prescribed by your school. Okay. Now moving to third part of question number 3. Now third part is Ck plus tan A multiplied with 1 minus sin A. Here also I am going to express sec A and tan A in terms of sine and cos. So sec A, I know it's a reciprocal of cos. So it will be 1 by cos A plus tan A will be sine A by cos A. Okay. And that is multiplied with 1 minus sine A. So if I take the LCM, you can see both the denominator is having cos A. So it will be written as 1 plus sine A by cos A into 1 minus sine A. Okay. Now here you can see A plus B, A minus B. So I can use A square minus B square, isn't it? A plus B, A minus B is nothing but A square minus B square. So I will write my A is 1. So 1 square minus B is sine A. So sine square A by cos A. So 1 square is 1 minus sine square A, okay, by cos A. And again the identity, we know that sine square A plus cos square A is 1. So from here, if I transpose sine squared A to RHS, so what it will become? Cos square A is equal to 1 minus sine square A. So 1 minus sine square A I can write as cos square A by cos A. So 1 cos A will get cancelled and I am left with cos A. So my correct option is option D. So option D will be the answer. Okay. Now moving to last question of question number 3. Now here it is 1 plus tan square A by 1 plus cot square A. Again I am going to write tan and cot in terms of sine and cos. Okay. So from here what I can write? 1 plus tan is sine by cos. So sine A by cos A whole square, and cot A is cos A by sine A. So cos A by sine A whole square. Okay. So now it will become 1 plus sine square A by cos square A. This is the numerator, and denominator will be 1 plus cos square A by sine square A. Now next step, take the LCM in both numerator and denominator. So numerator, if you see here it is 1 by 1. So LCM of 1 and cos square A is cos square A only. So it will be cos square A, and here will become cos square A plus sine square A. Right? Now let's see the denominator. Denominator also LCM of 1 and sine square A will be sine square A. So now it will be sine square A plus cos square A. Now after that, if you see cos square A plus sine square A, this is the identity, right? Cos square A plus sine square A, this value is 1. Just now we studied this identity. So I'm going to write in place of cos square A plus sine square A as 1. So 1 by cos square A divided by 1 by sine square A. Okay. Now 1 by cos square A. Now this is your division. So when you change division to multiplication, what will happen? This part will become the reciprocal. So it will become sine square A by 1. And 1 into sine square A is sine square A, and cos square A into 1 is cos square A. So further I can write it as sine A by cos A whole square. Isn't it? Because both are square. And sine A by cos A is tan A. So tan A whole square. So the answer will be tan square A, D option. So from here the correct option is option D. So I hope it is clear to everyone, because I've explained in detail step by step and mentioning the identities also where and all I am using it. Still, if you have any doubt, please feel free to comment in the comment box. Write to me in the comment box, and I'm going to clarify your doubt in my next video. If you like my video, please subscribe to my channel and share with your friends also, such that your friend can also get benefited with my video. Thank you.